Good morning, Latino youth. How are you guys? I miss you guys. Today's date is 5/19. Students will be able to work on exponential functions. So exponential functions, day 3, part 2. Exponential functions, more growth and decay. So first thing we're going to go over is the equation for an exponential function. So remember y equals a times b to the x. It's nothing new. We've talked about this all last week. A is your starting value, and b is your rate. All right, we will be working on writing function rules. Example 1, write a rule for the function with a given table. Determine if it represents exponential growth or decay. First thing we're going to do is look for our starting value. Our starting value happens, so A happens when x equals 0. So it would be 0, 32, which is our y-intercept or starting value. So therefore, our A equals 32. Now for us to find our rate or our B value. So now I have to figure out how do I get from 32 to 24. So remember, exponential functions, things are being multiplied. So I'm going to start off with this equation, 32 times m equals 24. Use any variable, to be honest. Solve this as we would a one-step equation. We should know how to do that. 32, m equals 24 over 32, which reduces to 3/4. And I'll double check right now using a calculator. Times 3/4 times 3/4 times 3/4 times 3/4. Remember, you know it's an exponential function if it follows the pattern that does the multiplication. So if my pattern here is 3/4, that means that's what my b is. So remember, y equals a times b to the x, which equals my starting value, which is 32, times 3/4 to the x. And determine if this represents growth or decay. Since the values are getting smaller, this is a decay function. So it's a decay because b is less than 1. 4. Write a rule for the function with the given table. Determine if it represents exponential growth or decay. First thing I'm going to do is I want to look for my starting value, which is what my y value is when my x equals 0. So then 0, 12. So I know that my a value, a equals 12. Now I need to figure out my function rule. So how do I get from 10.435 and to figure out how to get from 10.435 to 12, from 12 to 13.8. So 12 times a number, we'll call this number b. I think b is actually a better variable, equals 13.8. Now, what I'm going to do is I'm going to solve for b. Solve for b, I'm going to divide both sides by 12. And if I do that, I actually get b equals 1.15. If I was to take a calculator like this, then it would show me that this would be the pattern. 12 times 1.15. That gives me 13.8. 13.8 times 1.15. This would give me 15.87. 15.87 times 1.15. And I get 18. So the pattern is it goes by, it increases by a multiple of 1.15 each time. So 1.15, 1.15 times 1.15 times 1.15 times 1.15. So now that I have my b value, remember my function is y equals a times b to the x, which, since my a is 12, times 1.15 to the x. Now I need to determine if it represents exponential growth or decay. So looking at my v value and looking at my graph, since y is going up, or b is greater than 1, I know that this is a growth function. Next, write a function rule, then determine if the function represents growth or decay. The growth or decay factor. The growth or decay, I guess I believe it's going to be the rate, the initial value, the exponential function, and then I guess they want me to fill out the table. I need to figure out the pattern. So how do I get from 120 to 102? So I need to figure out what number I multiplied by, because it looks like this is an exponential function, because it doesn't go by a consistent pattern of add or subtract, and it doesn't follow a 135 pattern, which would represent quadratic functions. So 120 times b equals 102. Divide both sides by, again, this is now a one-step equation. Divide both sides by 120. B equals 102 divided by 120. B equals 0.85. So that means each time I go this way, I multiply by 0.85. 0.85. Let's double check. 102 times 5. 86.7. It works. So 0.85. So I know that my d is 0.85, but I need to find out what my value is when x equals 0 for me to find my starting value. So then let's do that. So going forward, I need to multiply by 0.85. Then going backwards, you need to divide. So then I'm going to do 120 divided by 0.85. So if I do that, 120 divided by 0.85, I get 141.18. 141.18. Because remember, around your decimal, then I need to also go by and multiply this guy right here by 0.85. So 73,695. 73.695 times 0.5. That gives me 62. And that gives me 62.64. 62.64. Now I have my rule. I have my starting value. So A equals 141.18. So now I could write my function. Number of functions are in the terms of y equals a times b to the x, which means that I have 141.18 times 0.85 the x. So that's my function rule. Now, does this thing model growth or decay? So I answered A here. Now, does it do growth or decay? I have two ways to look at it. This thing is a decay function because the values decrease. Or get smaller. And the fact that B is less than 1 but greater than 0. C, actually B, no, it's B, technically. My rate, remember that B equals 1 plus or minus R, depending on if it's growth or decay, plus if it's growth, minus if it's decay, and R is your rate. So 1 minus R equals 0.85. And if I solve this equation, I'm going to get R equals 0.15 or 3/20. D, find the factor. And my factor is 0.85 because your factor is actually your D value. So it's going to be 0.5. And the last one, so then I have my initial value. My initial value is 141.18. Oh, I have my exponential function, which I guess right here was E, filled in the table, which is F. And I did all that. Next, this one, Hawaii has been experiencing a 1.06 annual increase in population. In 2000, the population was 1,211,537 people. Write a function that represents the population P with respect to the year T. The trend continues. What will the population be in 2020? So remember that y equals a times b to the x, which equals a times 1 plus or minus r to the t, where it's plus if it's increasing or growth, or minus if it's decreasing or exponential decay, and t is the same thing as x. So this 1 plus or minus r is the same thing as your b. So then
Let's take a look. So my starting value is 1,211,537. So I'd use that 0 because that's your starting year. Again, year 2000 is your starting year. So this would be represented by the year 0. And then I have my 0, comma. I will use purple comma for this one because I have a large number here. And then I have my rate. So each year the population increases. This 1.06% is going to be our R. Since R equals 1.06%, we need to change that to a decimal by moving it 2 places to the left, which becomes 0.0106. I plug it into this equation right here. And since it's an increase, it's going to be growth, which is going to equal 1,211,537 times 1 plus 0.0106 to the T equals 1,211,537 times 1.0106 to the T, and that's my function. Now I need to have it represented. Now I need to enter the part for part B. If the trend continues, what will the population be in the year 2020? So I have my function right here, y equals 1.0106 to the 20, because remember, this is what the population is in the year 2000, and they want to know what the population will be 20 years later. So now I take that and I plug it in. So 1, 2, 1, 1, 5, 3, 7. That was 1.0106 to the 20. And I get 1,000,004 968.88. However, I will round up because I can't have a 0.88 of a person. So the population will be 1,495,969 people in Hawaii in 2020. Now for the next one, in 2000, in the year 2000, 2,200 students attended Polaris High School. The enrollment has been declining by 2% annually. Write a function for the enrollment of Polaris High School using T years after the year 2000. So B, if this trend continues, predict the number of students in the year 2015. So first thing I'm going to do is remember my function. So y equals a times e to the x, which equals a times 1. In this case, I'm going to be using minus because of the word declining or decreasing. I know that my starting value, because we start in the year 2000, is going to be, so it's going to be 2,200. So I know I have 0, comma, 2,200. I know that my rate, or my R value, this is my R, which 2% becomes 0.02. You got to change it from a percent to a decimal. Now I plug it into my equation. Y equals 2,200 times 1 minus 0.02 to the t, which equals 2,200 times 0.98 to the t, and that is that for that part. Now for B, if this trend continues, predict the number of students enrolled in 2015. So I equals, so then it's going to be 15 years after the year 2000. So I know that T will equal 15. So then I got Y equals 2,200 times 0.98 to the 15. I'll grab my calculator. 2,200 times 0.98 raised to the 15. And I get 1,624.85. 1,624.85. Remember, you can't have 0.85 of a person. So we're going to round up. So I have 1,625 students in 2015. And that is it for that problem. If you have any questions, comments, or concerns, feel free to contact me via email, via Remind, or via. I hope you guys have a beautiful day, and Mr. Othman is out.